So in the last tutorial, we saw that ImageNet is so-so for categorizing cats and dogs. It might categorize the wrong cat or the wrong dog family. It might give you toilet paper instead. I'm really harping on toilet paper this week. I don't know why. Probably just because it's the last class. So the key there is that, like, let's find a model that does what we want it to do. Now, if you're trying to classify, I don't know, recycled toilet paper versus non-recycled toilet paper, like the brown stuff versus the white stuff, there might not be a model for that. You might have to train your own, and we'll cover that this week as well. But sometimes there are tasks that will cover much more closely to what you want. It just so happens cats versus dogs is a very common example of what people try to test with. And I happen to have found a model on Hugging Face that was cats versus dogs. So I found that this person had already trained a model called ViT, which is Vision and Transformers, on cats versus dogs, and it has an accuracy rate supposedly of 99.3%. So this is, I'm lucky to find this. Sometimes you do, sometimes you don't. But that would be a good example to go through. So let's take a look at how this classifies compared to ImageNet. Now the downside of this is, remember, there's only two labels. So it means no matter what I feed it, it is going to choose between either a cat or a dog. So if I feed it a landscape, which there are some scenes of like very long, wide shots of landscapes, it's going to decide between a cat versus a dog of that image. And who knows how it decides that, but it's going to decide that. So we'll take a look at that, and we'll talk a little bit about how to actually work around that. So as always, let's connect to our notebook. I am going to use a GPU again because I'm actually going to skip the frame creation steps because we did that before. If you haven't done that before, check out that video on how to do it. The exact same cell is here in this notebook if you want to do it. Just go to Runtime, change Runtime Type. Let's make sure we're on a T4 and high RAM, and we'll hit Save. As always, we connect the drive because that's where all our videos are. Connect to Google. Log into our account. And allow. One thing I should also mention, I don't know if I mentioned this before in Collab notebooks, but you can always, in your notebook, if you're in the folders, you can also click on the little table of contents. And I've tried to arrange the table of contents to accurately sort of suss out the right layers here. This looks wrong, load model. That should be 2. So you can always jump between these if you know you want to jump down to a certain section. So let's start at the top. Okay, we're connected to our drive account. Again, we're going to skip the frame creation step here. Remember, the lower you set this, the likely the faster the model is. But you don't want to be too low in that you might only get one image and then you have some accuracy issues. The other thing I should mention is this model, again, only works on frames. It does not work on video. So we're going to need to use process a bunch of frames. Now we can go ahead and load the model. So we'll run this cell, which just loads the Transformers library. And then we'll go ahead and immediately run this model as well, which this loads in our model. And I'm not sure how big this is. We'll have to see how long this takes to load. Looks to be fairly fast, so that's good. Okay, so our model is loaded now. And now, just like before, let's use the model.config.id to label to see exactly what our labels are. Spoiler, it's already there, but let's just run it again to make sure. And we see the label index of 0 is cat, and the label index of 1 is dog. So again, this only does cat or dog. There are no other labels in this model. Let's go ahead and test this on a single image. So we're going to go to our folder. We're going to go to Drive. We're going to go to My Drive, our Algo Film folder, into our frames, and let's grab something from Milo and Otis. And again, I like to scroll like a little bit down into our folders because, you know, the intro folders might be production credits, they might be scene establishment, that sort of thing. So I like to go kind of like, you know, scroll down a little bit. Let's see what this one is. So let's just double click on this, see what we got. And there we go. There's a cat. So clearly we should see a cat when we run this. So let's go ahead and copy this path. Just right click on the file, and then you can paste that in at this first line. I'll make sure this also gets turned into a little form, so you can add it there if that's more your style. Let's go ahead and run this. And we see that it labeled that image as a cat image with a 96% confidence, 97% confidence. So that's really good. I mean, that's exactly what we would want to see. So now we're generalizing more here. We're not saying only find me a Milo cat. We're saying find any cats. And I think if I looked at that image again, it was not Milo. It was some other cat. So not always perfect, and that's why we're going to maybe use the ADL file for this. Let's see if we can find one of a dog, or find one that's actually like kind of generic or like hard to guess. All right, so there's a cat butt. Let's see if it gives us a cat. So we'll copy this path. We'll put this in here in this path, paste, and run. And it actually tells us it's a dog. And it tells us with 99% accuracy that that is a dog. Now, obviously that's not correct, but this is kind of the challenge of these tools is you don't always get exactly what you're looking for. We may have to keep an eye on this particular folder and see how that goes. So actually, let's run this on this folder. So I don't know what other images are in this folder. We could probably look while this runs and see what happens. But let's actually use this folder as an example to see exactly what we get. So process folder, we'll run this cell. We're just going to save in some functions that we're going to use. And this will do the exact same thing we've done in the past, which is we'll load in all of these images and process them and give us the average result, essentially. While we're here, let's go ahead and double click into a couple of these other images and just sort of see what we have. So there's nothing in that image. That'd be kind of an interesting one to try to see what it generates. And yeah, that one's the same thing. So it says, overall, it says dog. So I'm not sure why that is, but let's find out. If we double click into some of these other images. And actually, if we remove this, we should get both the probability and the label. So let's try that again. So again, there's another cat hiding in dog with 29. I need to look at what that actually means. So it's still giving us a dog. So again, this is not the most accurate model, but hopefully it's better than what we had before. So actually, what was I going to do? I was going to pull in 32 and run this and see what I got with that weird sort of roof image. Dog with an 87% accuracy. So again, it's less confident of that score, but it's still kind of overly confident for what it is. Now, if I were to find an image that had both a cat and a dog in it, I would actually expect the result to be one or the other, but the confidence to be around 50%. Because again, remember, 50% in this model will be a coin toss, which means it's not really that confident at all. So we can sort of see how we go and how we do here. Let's go ahead and skip down to the next layer, which again, this time we're going to process all of our clips. So this is already set up, and there's two things we can do here. So this cell, if we look at our table of contents here, we have process all clips or we have save to JSON. So because this model is kind of unique, and it might be something I only work with within Milo and Otis, the data set of Milo and Otis, I might not want to save this to my JSON file, right? If my JSON file is Groundhog Day, this, Pitch Black, other films, then asking for cats and dogs in that entire data set is kind of silly. But, you know, maybe long term I want to have the option to save that there. This first cell will actually just save everything or capture all of the categories, but not save it to your JSON file. This cell down here will actually save it to our JSON database. If you know you're only going to run this once, then this one is fine to run. If you know you're going to try to access this multiple times, then what I recommend you do is actually run this cell. Remember, this is not the fastest process. It took us an hour and a half to do this. With the other model, it's probably about the same length of time for this model. So we don't really want to waste an hour and a half. We know we're going to do it again later, right? Because then we're wasting 3 hours instead of an hour and a half. So when in doubt, run the save to JSON cell. But if you absolutely know you're not going to use it or are just playing around, then you can use the other one. Let's go ahead and run the save to JSON cell. I'm fairly certain I already did this. So it may just spit back that we've already done this. Yeah, so previously skipped. Yep, so okay. So I built this in so that you don't rerun things. You don't waste more time. So if it finds that you've already run this and saved it to your JSON dataset, it's just going to tell you, hey, I've already run this, and we can skip it. For you, if you were to run this the first time, it should just process everything like it has normally. Now, what can we do here? Well, the same thing we did last time was we grabbed the correct label or the label we wanted to categorize by, and then we generate a film from that. So let's go down here, and let's say combine by label. So we can go in here and just say, just give me all of the cat videos, right? Give me all of the videos that are, I would assume just Milo. Now there are other cats in that footage, which means it's going to be a little tricky. But let's get just Milo out of here. So we'll run this. And you'll see out of the 740 clips that are in that video dataset, 230 were cats. So if I switch this to dog, I should see whatever the inverse number is. Yep, 510. So this is going to give me a collection of data. Now, again, maybe this is also like more of a testing like scenario to sort of see like how many films, this is a very pro-dog film based on this data set. I don't know if there's actually more dogs or more cats in the movie. I would have to go watch it. But according to this classifier, there are more dog clips than there are cat clips, whatever that means. So again, we can go in and begin to work with this. Now, this one, interestingly enough, so one thing I also want to talk about was actually capturing the confidence score. So let's actually do that really quickly here as well. I'm just going to add a confidence score, min confidence, and we'll set it. Now, did I save that to this data set? See, the problem is I'm not saving confidence scores. So what I'll do is I'll actually update this notebook, and we'll look at using the confidence score as another filter on this. So I'll update this notebook, and then we'll talk about that. So give me 2 minutes, and I'll be back with that. Okay, now I've added in the confidence score. So now when you output your classifications, you will also get a score with it. And now you can use that confidence score as a filter mechanism. So in this case, let's say we want to let's grab the dog label and only look at confidence scores above 0.7. So remember, in this case, if there's a 0.5 confidence score, that basically means it's like a coin toss. So anything that's 0.5 is probably not really that accurate or not very confident in what it's seeing. So we want to grab anything that's above 0.7. So let's go ahead and do dog for above 0.7. And we get 464. And we switch this to cat at that high. We get 202. So there's like 740 total clips in this. So sometimes we're skipping some of them by changing that confidence score. If you want really, really high confidence, you could set this to, 0.85, 0.9. And let's see what that gives us for cat. Now only 149, so we've lost 50-some clips there. So let's go ahead and run this and see what we get. So let's go ahead and output this as our confidence score of 0.9. So again, I'll upload these videos and we can look at them. So this is probably more accurate if we look at the scoring here. You'll see a lot higher confidences here. Some things are kind of low, but a lot more 0.9s. And that's because, again, we've got only 2 labels it can pick from. So it's going to be a little bit more like leaning toward one thing or the other. So I'll upload the video when this is done. Let's look at one other option that is sort of a pre-trained model that will allow us to automatically sort of define our labels using what's actually more like a clip model. So we'll look at a thing called xclip next.